So like Scott said, my name is Raj Anand. I am a bridge engineer here at Heath & Lambeck Engineers. I am a recent graduate of Georgia Tech and have 5 years of experience with bridge design. So I'm still a learning engineer, but here I thought I'd give you all a quick introduction on some basics of bridge engineering and what really goes into it. So if you want to think about what's the difference between science and engineering, so you can define science as a body of knowledge that seeks to describe and understand the natural world and its physical properties. But when you come to engineering, it's essentially using our understanding of the natural world to solve society's problems with real life solutions. So engineering is essentially, discovering the needs of society, turning it into ideas, and then finally coming up with the real solutions to solve your problems for the society. That's what engineering essentially comes out to. So for all the parents and the kids listening out there, I just want to give you a quick idea of where bridge engineering comes in the world of engineering. So engineering has a lot of disciplines. There's mechanical, civil, chemical, biomedical, electrical, nuclear. So bridge engineering again comes into civil engineering, and inside of civil engineering, there's a lot of civil engineering. Again, has a lot of disciplines in it. So there's water resources engineering that deals with all the water systems in the cities, sewers, sewage, dams, all that stuff comes into water resources engineering. Geotechnical is a study of soil and earth and how it can support structures on top. So that's geotechnical engineering. So bridge engineering is again can be classified into transportation and structural engineering. So transportation engineering, because bridges carry cars and trucks, and it always ties into roads. So bridge engineering has a lot of transportation engineering in it, and obviously structural engineering to make sure that the bridge is capable of handling the loads that we put on it. And then finally, structural engineering has building design, bridge design, and then specialty structures. So that should give you an idea of where bridge engineering fits in. So a typical career path for someone who wants to pursue a career in bridge engineering would be, you graduate high school, and then you go to college, do your four-year bachelor's degree, and get a bachelor's degree in civil engineering. And then if you want to be a little bit more specialized, you can get a master's degree in something called structural engineering, or you can get a master's degree in any of the other disciplines that I talked about. So here, I personally have a master's degree in structural engineering. And then after you get 4 or 5 more years experience on the job, you can finally apply to become a professional engineer. And with a little bit more experience after that, you slowly start into designing structures and stamping plans. Okay, so now let's get into bridges. Give you a basic idea of what categories bridges go into. So there's essentially 4 kinds of bridges. There's beam bridges, there's arch bridges, there's truss bridges, and then there's suspension bridges. So let's look at beam bridges first. So these are the typical bridges that you see every day. So all highway bridges that you drive over every day when you're out there driving are essentially beam bridges. So this, I would say, makes up to maybe like 60–70% of all the bridges out there in the world. So this again is another example of beam bridges. So so this actually is the train that's in the Atlanta airport that takes you from the airport to the rental car center. So again, this is another example of a beam bridge. And how a beam bridge works is it has an element that's working in bending. So it's a single element here. And when it goes into bending, the top of the element goes into compression, the bottom goes into tension, and then that opposing force that develops here helps this element to resist load on the top. So next type of bridge that we are going to look at is our arch bridges. So this is the Hoover Bridge, or the bridge near the Hoover Dam. And so arch bridges have been around for a long time, from I want to say around like 2,000 years ago, and maybe even in the BC era, you've seen arch bridges around. So this is a very like old type of bridge, which is still being used, because it's still very strong. And the way an arch bridge works is you put load on the arch, and the load gets transferred through the arch and goes into the support here that resists the force from the top. So for arch bridges, what you really need are really good foundations at the end of the arch, because when you put load on top here, the load from the support here and here is what helps resist that force. So that's how an arch bridge works. Let's go into suspension bridges next. So these are the longest span bridges in the world are suspension bridges. They do have some drawbacks, with it being really flexible and being susceptible to a lot of wind and an earthquake. But then, new technologies have enabled engineers to, actually simulate wind loads, simulate earthquake loads better. So with the new technologies, these bridges are quite safe nowadays, and these are actually the longest bridges that you see in the world today. So this one is obviously the Golden Gate Bridge in San Francisco. Again, how a suspension bridge works is you apply a load in the middle, the load gets transferred through the cables up to the support and finally to the end through the cables. And then finally, let's talk about the truss bridge. This again is a very, I want to say it's more common than the arch bridge and the suspension bridge, but these are a little more rare than the European bridges. Again, your truss bridge works because there's a series of triangles here that are stable elements that help the bridge keep its shape. So here, if you look at three elements here, there's a square shape, there's a circle shape, and there's a triangle shape. And as structural engineers, we always prefer triangles because it's constrained on three sides, and it's difficult to change the shape of triangle, and it doesn't laterally flatten down. So truss bridges are made of mostly triangles, and a load here gets transferred to the end through a series of compression and tension members. So that is formed using the triangles. So today we're doing the toothpick bridge competition, and this is an example here. And I would say this is a combination of a beam bridge and a truss bridge. So if you look at it at a singular element level, like a microscopic level, or even like a small element level, this is a truss bridge. But if you have a lot of these components, it essentially acts as a beam of sorts. So it's kind of like a combination of beam and truss bridge. So let's talk about how to design one of these, and what should go into the design process when you're going into design one of these bridges. So engineering is often a trial and error process. So engineering always has evolved over time, where we've learned from our mistakes and gotten better and better over time. And so our mistakes from the past have helped us make better, stronger, and safer structures in the future. So that's a process that you should try and use while designing one of these bridges. So each time you make a bridge, try and see how the bridge behaves, how it fails when it's being tested, and the next time you go and rebuild a new bridge, try and incorporate the mistakes and try to not make those. So kind of like imagine what your bridge should look like. You plan, and then you build the bridge, and then improve based on how it performs, and then the process continues. Well, that's it. Well, I can give you some advice on how to build a bridge for next year, maybe if you're trying to attend next year's event. So tip number one is the depth of the structure is very important. So here we can see this bridge only has 2 layers, so it's maybe like 2 inches deep, and this bridge here has 4 layers and it's like maybe 6 to 8 inches deep. So you can try and imagine if you put a load on the top, which one will be stronger. To give you an example, let's say we have a 2x4. think of whether it'll be stronger if you apply load on the flat side or if you apply load through the long side. I guess you can come to the conclusion that you can try it out at home, and you can probably figure out that the longer side applied load has more strength and stiffness than the flatter one. So the deeper the bridge, the more stronger your bridge is going to be. The next tip I want to give you is make triangles. We talked before that we always like triangles in structural design. And the reason we do like triangles is because, okay, let's say we have a square shape here and we apply a load here. It has a tendency to sway laterally and fail, right? So how do you fix this? Is you put a member diagonally here now. So now when you put this member here, we call it diagonal bracing, and because of this member, it now can no longer slide laterally, and so it's stronger. So your tip number 2 is always make triangles and avoid square shapes. Finally, tip number 3 is you can try different types of glue. Different types of glue has its advantages and disadvantages. Some of them are very brittle and strong, while some of them are can stretch a little bit more. So you might want to try, make 2 bridges and try one each with different types of glue, see which one helps or which one works the best or which one is the strongest. So that's our 3rd tip for today. And finally, the most important tip of all, I would say, is have fun. Engineering, especially when you're a kid, should be about what you learn from doing something rather than getting it right the first time. So always have fun doing it. Finally, so me being from ASCE, I want to put this, introduce you to this documentary that's on Netflix. It's called Dream Big. So it's a very, I would say, inspiring documentary that you can watch with the kids. And I would, highly suggest doing that. It's a very, made with a lot of passion. It has a lot of videos of different kinds of structures, and it's very interesting. So I would ask you to go look up ASCE Dream Big or Dream Big on Netflix.